growing concern about the environmental effects of internal combustion engine vehicles has spurred development of electric vehicles. But what does an electric car really cost? To find out, let's hear from Robin Lindsey, Professor of Transportation Economics at the University of British Columbia in Canada.
So this paper is joined with Andre De Palma, who's in the audience, and then Yannick Rioux, who's connected by Zoom, and it's a work in progress. The intent was to evaluate electric cars in terms of the private cost of ownership as well as the social cost. And so far, we've just looked at the cost of greenhouse gas emissions. And most of the analysis relies on Yannick Rioux. He's currently at Beta, but for much of his career, he worked in the automobile industry. He has an engineering background, and he collected the data and did most of the calculations. So he's really the lead author of this study. But I don't think that electric vehicles require motivation, so I'm going to jump in now already to some of the statistics. There are some 500 models of electric vehicles in use today, compared to some 3,000 internal combustion engine vehicles. So there's still fewer electric vehicles than internal combustion, and that has implications for substitution. If someone wants to get an electric vehicle, which is as close as possible to the existing internal combustion engine vehicle, then they may not be able to do that, right? They're going to have something which may be more upscale or downscale. So there are trade-offs. As far as the power is concerned, of course, the internal combustion engine vehicle has only either a petrol or diesel, and it has a battery, but that's not for propulsion. Then we have hybrid electric vehicles with a very small battery, and they're recharged with the engine. There's no plug-in. The plug-in hybrid electric vehicle can be powered either by the ICE, internal combustion engine, or an external charger. And there's three types: level 1, 2, 3, which differ in the cost of obtaining them, as well as the rate at which the electricity is delivered. And then we have what you might consider to be the true electric vehicle, the battery electric vehicle. It has no internal combustion engine, so it has to be recharged externally. Now, we know there are various supportive measures for EVs, subsidies for buying the vehicle and the charging equipment, and then various recurring benefits, which include paying no tolls and having reserved parking spaces. This is an incomplete list. And there are also contrary restrictive measures for internal combustion engine vehicles, minimum fuel efficiency standards, which began nearly 50 years ago, bans from zero emission zones. There was a talk yesterday about that. Bans on the sales, and they're coming in year 2035 in Europe. And then, and I don't know about whether this is actually being proposed yet, bans on operating ECVs, ICEVs. That will probably be some time off, but it could well come. So what are the advantages of electric vehicles? Well, there are private benefits: lower energy costs, simpler engines, no emissions control equipment, and regenerative braking, which means that when the vehicle is being stopped, the battery can be recharged. It means less wear and tear on the brakes and so on. And those are the main reasons for lower maintenance costs. Now, the maintenance costs are going to vary. Things are going to change pretty quickly over time. So the data we use will probably become obsolete fairly quickly. Now, what about the social advantages? Well, fewer greenhouse gas emissions, but not zero unless you have a green energy source for the production of electricity. No local pollution. So what do we do in this paper? Well, we're going to make a comparison of electric vehicles and internal combustion engine vehicles and try to match them up as closely as possible. That's not always the case. The acquisition costs, the operating costs, and the greenhouse gas emissions. And the focus is more on the difference between the costs. So the title of the talk, what's the cost of an electric vehicle? It's really relative to the internal combustion engine vehicle. So what we do, following the typical practice in France, is to consider a lease of N years, and then it'll be 3 years in our analysis. It includes taxes because the taxes are a private cost. We look at the acquisition costs. So the vehicle is purchased, if you like, from the leasing company, and it's resold at a discount after N years. And the individual also pays the registration fee, the penalty for CO2 emissions and other taxes. And then in the case of electric vehicle, you have to buy the chargers as well if you're going to do that at home. Then there's the operating costs, which include the energy, the maintenance, the insurance, and then a charger subscription fee if you want it, and that'll reduce the cost of recharging. So the equations here are pretty straightforward. The first equation says that the cost annually to operate the vehicle is the product of the price of the fuel, and then a factor which accounts for inflation, which could be specific to the fuel, whether it's petrol or diesel, and then the consumption per kilometer multiplied by the number of kilometers. Similarly for these other costs, and then a simple equation for that cumulative inflation factor. As far as the acquisition cost, we assume that the vehicle is not damaged when it's resold, and that the insurance that the person pays is for someone who hasn't been deemed responsible for an accident. Here are the equations, taking into account the technological depreciation, which depends on the type of the vehicle V, and then how many years the lease operates. Physical depreciation, which depends on those two variables plus the kilometers. And we assume that the two factors are interactive. So there's the resale value that the person will get at the end of the lease, equation for the cumulative inflation. And then if you do the same thing for the taxes and the electric charger, you get this as the equation for the total net acquisition cost. And then it's assumed that the person doesn't pay cash for the vehicle. Rather, they take out a bank loan at an interest rate of RB, and then they pay it back in equal annual installments over the N years. So you get this equation for how much they're paying. Now, this is a comparison of costs, not the benefit that the person obtains from the vehicle. And there can be differences between electric and internal combustion. Charging time is a disadvantage for the electric, but there may be advantages in the quality of the ride. It's quieter, smoother. You're not changing gears. The privileges such as access to toll lanes without paying, and then feeding the grid. You recharge during a time of day when the price is low, and then you feed back into the grid at a time when the price is high. You can actually make money, and that also helps in terms of having adequate capacity in the electric system to meet the demand for electric vehicles as well as for all of the other uses. Now, the social costs depend on a number of things, and so far we've only included the greenhouse gas emissions. Local pollution matters a lot more, but that depends on where the vehicle is run, right? So you have to compare, let's say, center of Paris with rural areas, and then there's costs which are not known precisely for particular models. The extra cost of manufacturing the battery using raw metals, recycling the battery, and that technology is rapidly changing. And then there are other externalities where common to both types of vehicles. Congestion is going to be the same if the vehicle is the same size. Safety, a bit of difference because the electric vehicles are heavier, which is good for the occupants, but bad for other people if there's a vehicle crash. And then the noise, the electric vehicle will have some advantage there. And what about the greenhouse gas emissions? Well, the cost of that for the electric vehicle depends on what source of energy is used on the margin. And this diagram shows you that cost varies greatly around the world. In the case of France, it's pretty low, 72 grams per kilowatt hour. It's cheaper in a few other places, marked in dark green, Scandinavia, for example, but it's much higher elsewhere. And the worst offender is Poland in the EU, right? The pollution costs are more than 10 times as big. Now, how do we deal with that? Well, there's a complication in the EU because of the emissions trading system. And in principle, the cost of the greenhouse gas emissions should be included in the price of electricity, but there's some debate as to whether that's the case. I think Steph has an opinion on that, and he can contradict me when he speaks. Right, so we're ignoring that. That's something to be looked into later, and it could take some time. And what about the emissions of internal combustion engine vehicles? So that's not yet in the ETS system, although there's a plan to add it a couple of years from now. So what we do is we evaluate the emissions from the diesel fuel or the petrol fuel at 100 euros per ton. Some analysts think it should be perhaps double that, but this is a benchmark figure. And then again, adjustments should be made because the fuel taxes are pretty high, and particularly in France. And those taxes may cover externalities, although it's indirect. Right? So if you look at the taxes measured in tons of carbon dioxide equivalent, it exceeds the $100. Right? But those taxes are covering other things in principle, like congestion and so on, and also it's a revenue generator. So that's a complicating factor. And it's going to depend on the country. We have some information for France, but we haven't put it into the calculations yet. So the vehicle sample is this. We have 52 models, and they're either Mercedes or Renault. Of those 52, just over half are gasoline, 15 diesel, 6 plug-in hybrids, and 4 battery electrics, and none in the other two categories. 5 body types listed here from the smallest to biggest, and then of course the cost of buying the vehicle, leasing it, and then operating it's going to depend on the equipment, and we assume, or Yannick assumes, that it was the average equipment representative of the particular vehicle. So it takes a lot of information to get that for even a sample of 52. Now the fuel consumption as well as the emissions will depend on speed and acceleration. And the way that that's measured is using the so-called Worldwide Harmonized Light Vehicle Test Procedure, which has replaced an earlier, less accurate system used in Europe. So what is done is the vehicle is run for 30 minutes over a course of 23 kilometers at different speeds, 4 categories. And the first is low speed. You can see a lot of start-stop, which is going to increase the emissions and the consumption of the ICEV more than the electric vehicle. And then 3 other increasingly speedy profiles, which are representative of rural travel. So what is done in the calculations is to consider either urban travel, which is going to be in the first category of the WLTP, and then the rural, which covers the other 3, and then take an average, so-called combined, for the representative traveler who does a certain amount of driving in the city and the rest outside. But in the case of the plug-in hybrid electric vehicles, you have to take into account what fraction of the running is done on the battery and what fraction is done on the fuel. In the urban area, it's going to be almost all electric, but the ICEV, or the internal combustion engine, needs to be run occasionally. Otherwise, it's going to stop working. We need the fluids to be circulated and so on. In the case of the combined, we have a formula, and I won't take the time to explain that. But it does mean that if you're going longer distances, then because of limited range of the battery, more of the driving will be done on the internal combustion engine. Here are the parameter values. I'll just highlight some of them. There's the pollution penalty, and it's actually a subsidy for the best vehicles, and that'll be in our example. And then the penalty can go up to 35,000 euros for an SUV with a engine over 300 kilowatts. So it's a great range there. We assume that the vehicles, regardless of type, are driven 15,000 kilometers. Well, that's not accurate, but in order to have a fair comparison between the two vehicles, that's the assumption. This is an average driving distance in France. The electricity cost depends on whether you're doing it at home, whether you have a subscription for which you pay annually, or whether it's without a subscription. You can see quite a difference in the prices. What about the inflation rates for the various components? Well, if you look at recent developments, there's been substantial inflation, the most for the battery electric vehicle, 11%, but that's not likely to persist. We hope that COVID doesn't come again and supply chain problems don't emerge. So what we do is we assume everything is zero, including the general inflation, which means that 5 minutes, the real prices, I have to skip some slide. To assume the real prices don't change. Right, so the comparison method, as I said, will involve trying to find 2 models, an EV and an ICEV, which are comparable. So let's look at a case where they are very comparable because the body's identical. And this is one of the compact vehicles, a Twingo, the petrol version, and the battery electric vehicle. You can see that the battery electric vehicle is nearly 200 kilograms heavier, even though it's a battery of modest capacity. It has much less power than the internal combustion engine, and yet it accelerates a lot quicker, which shows you an advantage of electric vehicle, which is of course relevant to the customer, but since we're looking at costs, it's not a factor. The price difference before the subsidy is nearly 10,000 euros. It's substantial, but there's a $5,000 subsidy from the government, which reduces the cost difference to a little less than 5,000 euros. And then here, the costs in the case of the combined driving, combination between urban and rural. The electric vehicle cost about 700 euros more, but the variable cost is about 250 euros per year lower. So the differential is around 400 or 500 euros. So let's look at how that varies now. This is the sensitivity analysis, so the break-even analysis, which has been done in other studies. So here we're varying the distance. We're assuming a base case it's 15,000 kilometers, and you can see that the battery electric vehicle is more expensive. That's 450 euros. But if you go further, then the electric vehicle gains more an advantage because it's cheaper to operate. And then the break even is about 27,000 kilometers. Few people actually drive that far, but you see, and someone who drives a great deal might find a battery electric vehicle cheaper. We vary the price of gasoline. Of course, it has no effect on the battery electric vehicle. The green line is horizontal, but the petrol cost goes up, and break even is at about €2.30, and the current price in France is about 183. So if the cost goes up by 50 euros per liter, then the battery electric vehicle will be cheaper. Then we can also vary the how long the lease is. Benchmark is 3 years. If you extend it up to 10 years, which is as far as our calculations have been done, there's still a gap, but it's a lot smaller. Right? So longer lease is an advantage because the higher acquisition cost of electric vehicle matter somewhat less. So what I'll do, I'll have to skip this. So these are tables comparing the whole sample of 52 in terms of the body type, in terms of the power plant and increasing power, diesel, petrol, plug-in hybrid, electric vehicle, and electric. And the results are broadly consistent with what you get with the Twingo. Right, so I'll skip that and go to the greenhouse gas emissions. You get a difference between urban and combined. In the case of urban, a plug-in hybrid engine vehicle, which is comparable to the petrol, the engine power is the same. You can see the emissions are much smaller for the plug-in hybrid, but for the combined, the difference is much smaller because the plug-in has to be operated with an internal combustion engine, and then it loses the advantage of the lower emissions from the battery power. And then here's a case of roughly comparable models where the electric vehicle has an even bigger advantage, both in urban and combined. So you can see the advantage there is with vehicle type and other things. Now let's look at the greenhouse gas emissions, looking well into the future. The left panel here shows the number of vehicles in the fleet in France. It's now over 35 million. And then at some future date, they're going to be all replaced by battery electric vehicles. And what we want to do is to see how quickly greenhouse gas emissions are going to drop. Well, that depends on the lifetime of the vehicle, since it's a survival function. How many vehicles ICE will still be operating so many years after they were operated. And then there's a new vehicle sales. Currently, it's a little under 10% in France. Target rapid increase to 40% in 2025. And then if the 2035 ceiling is binding, then only electric vehicles can be sold. Right. So this appears that's reproducing that. And there's a stock of vehicles, which of course 1 minute. Right. So that, and then here's the forecast of the CO2 emissions. Right. This is just repeating what was on the previous slide. And then you can see there's a decline in the CO2 emissions measured in grams per kilometer, dropping almost to zero in 2055. So let me skip about retrofitting. And here's the conclusion, really, and it's really looking ahead. What matters as far as the advantages or disadvantages of electric vehicles? Well, of course, a lot of things, and I'll highlight just three shown with the red arrow. Smaller batteries for urban driving. That was proposed by McKinsey in a report. So if you're going to drive your electric vehicle only in the city, maybe you have an internal combustion engine vehicle and you use that for rural, then why not install a much smaller battery? It'll be cheaper, the vehicle will be lighter, and the operating cost will be less. Another factor is that manufacturing electric vehicles is expected to be much less profitable than internal combustion engine vehicles. And the manufacturers, of course, want to make money. So what they may end up doing is charging people extra. And BMW is already charging people for heating the seats in the winter. Right, which means you don't really own your vehicle, that the company still has a control over you. And then the fiscal implications, and Stephanie Peer has a joint paper which addresses that very nicely. Right, if electric vehicles are no longer paying fuel taxes, and maybe the operating costs are lower, so there's less general revenue obtained from them, then the government's going to be getting a lot less revenue. Some charges will probably be introduced, like distance-based, and that's going to reduce the advantage of electric vehicles. So I'm out of time. Thank you very much. Yes, yeah.
So you can give us a number, which is the resource cost of the car plus the environmental damage.
Yeah, well, that's something to be done, and it could make quite a difference, right? Because the battery manufacturing, as far as I understand, has as much environmental cost as the body. So that's going to be a disadvantage for the electric vehicle. And then what happens to the batteries? Well, sometimes they can be refurbished, and then other times you take the rare metals out of them, and that's most of the value. But of course, the profitability depends on whether lithium, cobalt, and nickel, and so on, what happens to the price. And they've been fluctuating. They reached the peak and they're coming down. You have new mines for lithium being developed. It's very rapidly changing environment. Yeah, well, the question had to do with the environmental cost of manufacturing vehicles, and in particular the battery for the electric vehicle. And then what about the disposal of the battery? There's going to be environmental cost, and then, of course,
Yes.
monetary cost as well. So how important are they, and how are they going to change in the future?
I think that the change in the future is today when we manufacture a battery, we import all the materials from other parts of the world. And we begin to see that by some manufacturers, for instance, Volkswagen, they have start a collaboration to recycle batteries. So what is very interesting to follow is the percentage and to control the percentage of the battery that will be recycled. Because when we recycle it, of course, we don't import any materials. And so the study begins to appear. What is important for us now is to have a good following of the percentage of batteries that will be recycled. It's very important for the social cost. And because it is a new technology today, the number is very small, but we can imagine, as you have seen the green curve presented by Robin before, that the percentage of EVs will increase very, very much. And so we have to control that the percentage of recycling battery increase exactly as the green curve. Very, very important for the social cost.
Time for one more question. Yeah.
You mentioned the back of electricity into the grid.
Yeah.
It's already in.
I think Steph knows something about that. If you want to answer that question, Steph.
I think it's not yet in place in many, but there are a lot of experiments, and it's really necessary in Western Europe, where we depend very strongly on highly fluctuating renewable electricity, wind, solar. And I think our computation was that it can make a difference of 300 to 500 euro per year extra benefit for the electric car. So, but of course, yeah, before people trust it, etc., you need an extra installation, you need a two-way interaction. And of course, I guess in France, they will be among the first to do it.
Yannick, do you think so?
Yes, partly. Yes, partly. The problem, of course, to manufacture battery in Europe, it's a good thing, and it is beginning. So we have seen in France recently the opening of several battery gigafactory in north of France. After that, the energy to use, it's a very, very difficult question. What is sure that in the 10 next years, we shall have clean electricity and much less clean electricity. And the nuclear plant will appear, the new nuclear plant will appear only in 10 or 15 years. And from today to this time, of course, we will have not sufficient clean electricity for everybody. So what we have to, there will be a choice to do. So clean electricity is for batteries, it is for heating people, it is for industry, it is for whom. So the increase of clean electricity is sure, but during 10 or 15 years, it will be not at all fully clean, not at all. And that is the question. And we have to take care to take the average electricity that we have in all our calculation, because we shall never know if it is clean or not clean. Exactly. And if we use clean electricity for heating people, it will not be used for battery. If we use it for battery, it will not be used for heating people and for industry.
The point I wanted to make is that sometimes we have really a lot of renewable electricity, like certainly in California during the day. So at that moment, you should recharge, and then this will be available for the grid in the evening hours. And in Belgium, we count on half of the maximum load for the moment. We count on electric vehicles to supply it at some moments. So we really count on it. And either it works, or otherwise we have to really install much more, say, peaking plants, things like that. But there's no need to.